Hello everybody, welcome back to another edition of the EcoStruxure Machine Expert training. I'm your host, Leandro Mada, and in this video what we're going to see is how we can use the M251, in this particular case, as a master in a Modbus serial communication with a slave, that in my case is going to be a M221, and how we can exchange information using the PLC communication library. So let's go to the software. So what we're going to do is to use this PLC communication library, and inside we have the ADDM, read bar, write read bar, and write bar. That's going to be used for the read and write information. Okay, so if you go to our software, if you want to use this, then the important thing is that we need to configure the serial line. So on the serial line, we just need to define the parameters that we're going to use. Okay, in my case, I'm going to communicate with a Modicon M251. So this is the Modicon M221. Okay, is 9200 even 81, and it's the slave number 10. Okay, so this part, imagine that this can be this PLC or any other device. Okay, try to make it generic as I can. So this part is configured, it's done, so it matches. Now we need to add this slave in the serial line. So here we just need to add this Modbus manager. That will be the one in order to use inside the program those function blocks that we had in the PLC communication library. Okay, Modbus manager. Okay, and here is where we define if the PLC is going to be the master or slave. So here, our PLC is going to be the master. As you can see, there is no address at all, which is fine. And then here is given the possibility to use RTU or ASCII. In our case, we're going to use RTU. So that's it. There is nothing else to configure here. Okay, even if you have this add button, will be more for the ASCII thing, but if we use the RTU, nothing else to configure here. Okay, so if we're going to use now the Modbus serial, we need to check on the communication port that we have. Okay, so basically in Modbus we have 3 cables that we need to use, the pin 4, 5, and 8. Okay, and probably if you have problems, you just swap the 4 and 5 in the device that you're going to communicate with. Okay, so that's it for this side. Okay, as you can see here, we have this communication library, and if I know wrong, it's already embedded when you are working with it. So the idea will be to build something similar to this, where I have the ADDM and I have read bar and write bar. Okay, we're going to see that the ADDM basically just define the structure of the address that needs to be used. You can take a look over here, to be used over here on the read and write parameters function blocks. Okay, but we are going to go into more details because this ADDM is also available for Modbus TCP. We just need to define which is the port. Okay, now if you open the online help for the Machine Expert, or we go for example for the ADDM, we should be able to see all the information that we have. So we have the ADDM, and inside you can see this structure. Okay, that basically will be linked to the other function blocks. These function blocks needs to be only execute just one time because it's the one that generates the structure. Okay, so if you make a change, you need to execute it once again, but it's not mandatory to execute it every time. Okay, so in our case, this is just an example how to do it. But in this case, it's executed every time, but I don't think it's going to be necessary. So here you can see the structure using the serial line for the address, which is the input that you need to use. So here is a string variable. This string variable needs to have the port that you're going to use, which is this link number. Here you can see the value. I'm using the COM1, so it needs to use 1, and then the dot and the slave address. Okay, this is what it's done. So that's it basically. So let's try to create a project. And I'm going to use that one. So I'm going to create a new project. So it's going to be comms serial. And we're going to use SCFC. So the first thing that we need is the ADDM, instruction ADDM, instance ADDM. It will create everything over here. So one thing that you can do, because this is inside this PLC communication library, but it has the library name shortcut, which is sen.addm. That is appear over here. So if you go to the PLC communication, it has this namespace sen. So here we just need to define the structure. So it's going to be a structure my M7.1, or it could be any device, my device. Okay, and we create the structure, and inside the structure we have all different things that we saw over here. Okay, that we have over here. So this is the structure again, you can see here, but this is something that the block will deal with. We just need to define the port number. It's going to be the 1, and then the number of the slave. So go back here, the address, we can define the string. So it's going to be port 1.10. Okay, and we're going to use these commas. So it's a string, or what you can do is to define device address, and here the initialization you can define 1.10. And that's it. Don't remember if I need to use this again here just in case. And then here we just need to do the execute. So x init, and then we have, if we have an error or something, we have over there. Now, this is to initialize the X structure that we're going to use in the function blocks. Now we need to use the function blocks. So cn dot, we have a read var instance. Instance read. Dot write instance write. I believe, if I know wrong, I already explained this using Modbus TCP. So it's going to be the same idea. Okay. So I have this. Here I have the possibility to initialize this. So it's going to be x cmd read, the command to read. We can use the command to abort, cmd abort. Okay, and I'm going to use this same command to abort over here, or the abort for the right. Okay, so we use that command here, cmd right. Okay, and here in the address, we just need to use this one, which is the structure. As you can see, it's an input and output. So we need to use this result in ADDR. There we go. And again, here. Good. Now, This is just the beginning to send the command to read and write. Now we need to specify the timeout. If there is a problem between the communication, the two devices, we can specify a timeout. We need to define the object that we're going to read in the other side, okay? We need to specify where to read and the amount of information, okay? Then, where the information in our master is located to read and write, like a buffer for that information, okay? So, if we go back to the help, here in the help, we have read and write, read bar, and here in the read bar we have all the things that we need, okay? If we go type of object to read, we have this table. So depending on the Modbus function that you need to use, okay, in order to read information from the other device, then we need to use this table. This is going to be the best one for you. So basically here we have, depending on the function block that we have different function, Modbus function that we can use, okay? And the definition of which function to use is this enumerator over here, which is the object type. And if we go to our software, here we have the object type. So in order to define this, we have send dot object type dot, here we can define. So I'm going to read the holding register. Okay, so if I use the NWU object type and the read bar, it means that NWU read bar and using the function tree read holding registers, which is what I want. Okay, I can use the enumerator or I can just use the value 0. Okay, but just like this, 0, it's gonna be fine. The problem is that I don't really know if I see the 0 and I don't remember. Okay, I don't see what I'm trying to read, so that's why probably the best is to use this. And the same for the write object type. I'm going to use I'm going to write a holding register. If we go back to here, write using the multiple writing. Okay. So far so good. There is no issues. So we need to define now. Whoops. There we go. The timeout. Let's just try to find the timeout examples. Let's see. Well, I don't remember right now, but I believe it's in seconds. Okay, probably need to double check that. Much better. Let's see. Parameters. There we go. So here, this is the timeout. Okay, generate parameters. Here, timeout exchange is a multiple of 100 milliseconds. Okay, so if I specify here, I don't know, 2 seconds, it's gonna be 20. Okay, let's kind of specify 5 seconds. The same can be applied here. So after 5 seconds, we have an error of the communication. So here, just to don't forget, timeout. Just a clarification that is in hundreds of milliseconds. So that's fine. Now we need to define where to read and write information to. So in this particular case, I'm going to try to read and write some specific register on the M2.1. So on the M251, I have already specified this database where I have this information. So this MW50 I'm going to read, and this one MW60 I'm going to write information to. So the first object will be the MW50, so in theory will be 50. And then the write will be 60, which is fine. The only thing is that you need to check if you need to add 1 or subtract 1 to this, so we can test this out. Now, the quantity is the number that we want, so it's going to be, I don't know, 5. I'm going to read 5, and I'm going to write 5 registers. Okay. And now here, the important thing, the buffer. The buffer is going to be the place that I have on the master in order to receive or write the information coming from the other device. So for that, if you take a look here in the example, here, sample, no, this one. Here we have an example how is the structure of the buffer. No, it's not here. See in the other example. No, okay, I thought it's gonna be here. Don't worry, don't panic. So the structure, if it's fine, here we just need to use the ADR, okay, and then just put something over here because it's just a pointer, okay. This is something that you need to put over there. It can be a word, okay, but in my case I'm using, I need 5 words, so I need to do something else. So for that I need to use an array. So if we go back here to my example, this is the definition of some of the arrays, okay. So I have these two, just going to copy and paste it over here at the top. That basically we just need an array of words, so array receive and array send. It could be 100 or less, doesn't matter. So in my case, it's going to be to 0 to 4 because it's just 5 elements. And here, just need to use those. ADR for address, receive, and then here the same but for the other one, ADR are sent, which is fine. Okay, now that I have this, I say, wow, fantastic, seems to be working fine. Not that true. So what we need to do is to read this data. How we can read this data from here? Well, so let's create a few more things. So I'm going to change this to this view. I'm going to use M251 MW50 word. I'm going to create the variables here. So just creating the variables over here. So it's going to be N5, 2, 3, 4. This is going to be 1, 2, 3, 4, 5. No, 0, 0, 1, 2, 3, and 4. And here we just the number 60. Brilliant. So we have this part, which is fine. Let's just move. We have the information here. So we receive the information and then we want to send the information to. So in order to get this out, we just need to use the move. So we just need to read from this element, array receive, between brackets, the first element. And the first element in theory would be the WM221 underscore MW50. Okay. So there we go. So now this is for reading information. Now for writing is the other way around. So here, just move this value here. It's going to be the 60. And here we just need, instead of receive, we just need to use the send. Okay, now I need to organize all this. Execution ordered by data flow. All right, execution ordered by data flow. You don't see it. Execution ordered by data flow. Okay, and it will organize execution of all these function blocks. Now that everything seems to be fine, okay, we can download this. But we need to be careful if there is an issue on this communication error and operation error. Okay, for that I have created in the library to communication we have these two, Modbus serial mode TCP, just to know what was the problem if there is one, as I have done here. Okay, if there is an error, we have these two. So I can copy and paste this out. Communication error. Then we have the name, everything in text. So read error. Much better name. Read com error string as read upper error. Oof. Upper error. The same thing can be applied for the other one, for the writing, in case we have an issue, but there is no harm to doing it, so let's just add it. Now that I have modified this, just need to use execution order by data flow. Now, if everything is fine, we should be able to read the device and see what's really going on. So, M258, going to connect, Alt F, yes. Okay, going to read this, going to start. So, something that I haven't checked is I have created the POU, but I didn't put it on the task. So this is not going to work. There we go. There we go. Online help, down. Okay. Okay, good. Just wait for it to finish. Okay, nice. So I connected with the PLC. Now, this is the address. I just need to initialize this. Okay, now if we go to my structure, my device, you can see I'm using the COM1. Then the unit ID that's going to be the slave device is number 10. Okay, so this information is done, and I got the done over here. In case I have something wrong over here, it will give me an error. Now I need to execute this. So let's put some data over here. 111, 222, 233, 444, and 555. Okay, as I haven't tested with this device, probably we just need to add or subtract one, or just leave it as it is. But I just want to double check if I'm reading the same information or not. So now that I have the timeout, I have the object type, I have the first object and the quantity and the buffer, I just need to send the command to read. Now, here, if everything is fine on the receive, we should be able to see the information. Okay, and here you can see I have all the numbers. So I'm receiving the information, which is fine, and I have the done, which is good. And if you take a look over here, I have the value and it's moving to this value over here. Okay. Now, for the writing, let's say I'm going to use over here. I need to put the new information. So it's going to be 147, 258, 369, 159, and 75, blah, blah. Okay, I'm going to move this value. So now when I execute this, it will move the information and write on this area. So here you can see that I don't have any problems. Exchange is valid. So now I'm going to move this. Okay, send information, which is fine. I haven't. Okay, so even if I move this information over here, the thing is that I didn't make the move, so I will only be sending the NW60 on the other side. So everything will be in 0. So let's test this out. So all these 4 numbers will be in 0, and this one will be the one that I have configured. So here there is no errors at all. You're going to busy and then done. Remove that, and then if I go back here, you can see 147, which is fine, good. Now, this is fine if you want to send the command at one specific time, which is good. Now, if we just have all this, maybe we can have this thing. So we can add something called the blink. So the blink instance com time. We can specify how often enable com. We can specify the time that we want this to communicate with the devices. So it just generates a square signal, a Boolean signal. So here, instead of having this cm this command, I can use this. So the time we're going to be every second I'm going to send information. So I need to generate in time high and time low. So it's going to be t milliseconds. Okay. This is the structure for this is a time variable. And here we just need to send this out. Now, in order to avoid having complications, and I will send this as soon as this one is not in busy. So I'm going to use Ctrl+C. I'm going to use the instant name dot busy, and here what I'm going to do is to specify that is not in busy. So right click the point, negate. So if this one is true and it's not in busy, okay, then it can operate. Okay, now then this done, I want that after this done, this one is executed. So instance rd dot done, it will execute this to send information. And what I want is to avoid this one, to execute when this one is working. So I can add another pin that negates when this one is busy. So everything is fine. Busy. It will send the communication once again. So sales execution order data flow, and then let's see what happens. So the idea is for me not to constantly trigger everything. So init, play, init, okay, and then just enable the communication. You can see it's doing something, it's reading, or it should be reading. So let's see what happened on the other side. So let's see what happened over here. So I'm going to move this. I'm going to change the value to 458. You can see I'm reading the value 458, 754. Okay, la 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 la, and it's reading information, which is fine. Now, if what happened if I write this out? Sorry, here, pum pum pum, 445, and you can see it's reading information. So using the blink in this way will allow you to execute and make the movement without you to execute everything. What is going to be good if you initialize, you need to initialize this at least one time. Okay. So this is just the beginning for this. Okay. What we're going to do later is to encapsulate this in a block and how we can execute this process in a different way. So this is just a beginning for the PLC communication over Modbus serial. Okay, once again, remind that you need to use the ADDM, the read bar or write bar, and then check the object type, that the object type is on the help manual. Here on the help, you can find information, okay, on the link number, which is the link number that you need to use. The object type that is important, which is the information that you want to read. So, so this is it for the moment, okay? And it's important to know the addresses that you want to use and which function are available, are compatible on the other device. So this is it for the Modbus serial communication using the M258, but it's going to be the same for the M241 or the M262. It's going to be exactly the same function blocks, the same configuration. So this is it for the moment, okay? Then we're going to see later how we can improve this and encapsulate the communication. So thank you very much for watching this video, and I see you in the next one.